Yo, this is my robotic arm demo. So this video is going to have three parts to it. The first part is going to be the demonstration of the robotic arm with some side explanation. And then the next will be the schematic, so the circuit diagram. And then the last part will be the code, which I have on my laptop. So I will begin with the robotic arm section, the cool part. Okay, there's three servos for this arm. Let's see if I can rotate it so it's easier to see. Okay. Oh, I also apologize in advance. I taped the bottom servo in the wrong orientation, so the wires get more in the way than I want them to. Normally they don't. I have another video where they don't get as much in the way, but I taped them in the wrong orientation, and I haven't bothered to fix it, but yeah. But anyways, servo 1, this bottom servo, this is in the code, this is R1. I called rotational because this rotates the whole arm. This is a J1, joint 1. This is J2, joint 2. This is grab, for grabbing things. So, oh, let me get these wires so that they don't touch for sure. Oh my god, they're touching. Why? Why do they do this? Okay, so I'm just going to demonstrate each joint. Each servo has 180 degrees of motion, which is suboptimal. I also oriented them a little wrong, so there's only certain ways it can grab stuff. But it's not bad. It's not a bad orientation. Here's rotational. Should have 180 degrees of motion. I don't want to pull any wires out, so yeah, that's all the rotation I'll do. And then this is joint 1, as you can see, turning down. Pretty good movement. I also had to change some parameters for the servo so that just in case I get like a power spike or something, or like something gets disconnected, the servos will go crazy, right? I don't want any combination of servos to swing so hard that it actually breaks the structure in of itself. If I rotate this towards the camera, you'll notice that all these servos are in line, meaning that if this servo spins down, it can spin this joint J2 into R1, which could potentially shatter the whole system. So because of that, I have parameters, especially on this servo right here, to not swing at that far. Yeah, it's still possible to happen if I get a really weird power like spikes and stuff, but it should never happen under normal circumstances. Yeah. Okay, and then so this is rotational 1, this is joint 1, this is joint 2, and then I'll point to the camera so you can see the grab. There's the grab. It's a very interesting mechanism. I glue a piece of wood to the top propeller of the servo, and then perpendicular to it, I glue another piece of wood that is in parallel with another piece of wood that is taped onto the servo. To make these pieces of wood grip better, I used hot glue on the tips. They're a little sticky still. I mean, it's not sticky. It's sticky just because glue is like naturally good at touching itself and being a little bit more adhesive than like metal or something. So I have another video where I pick something off the ground and then drop it, but to just show that the grab is good. Here's the grab. And what's nice is that you can hear when the servo is actively working because there's a buzzing noise, so you can tell when it's actually grabbing. So look, listen to that buzzing sound. That means the servo is working. And then you can let go if you open it up enough. So yeah, that's basically how it goes. Yeah. Okay, so that's that part. And now I'm going to take the camera off my stand and talk about the schematic. This is the schematic of the robotic arm. So I don't have the robotic arm like drawn out, but basically each servo is an SG90. That's how I drew the servos, and so each servo has 3 pins. So the red is voltage, like 5 volts. I mean, no, it's 9 volt. Wait, it's 6 volts. It's 6 volt, and then black is ground. And then the left one on each servo is actually green. It's a little hard to see. This is the data cable. So you need data to specify what orientation the servo is at. And the rest is basically just power. It's pretty straightforward. 6 volts. How do I do 6 volts? I put 4 batteries in series. And then lastly, I have 4 potentiometers, each 10K ohm. Oh, let me focus on. It's hard to focus on a digital screen sometimes. 10K ohms. And so you'll see that each one of these goes to an analog one. So what will happen in the code is I will read the analog input from the potentiometer, and that is going to, and then that, whatever that data is going to go to this data cable for the SG90s, and it's going to adjust the servo. So that's how it goes. Basically, if you were to draw an interior schematic of this Arduino, the A0 would go through something to convert it, and it would go into the other pins of 5, 9, 10, 11, or whatever. Yeah. Okay, so my robotic arm just fell because my taping job was bad, but that's okay. Why is it buzzing? Let me just disconnect everything. All right. Okay, so I noted that I need a prototype board to connect some grounds in terms of organization. Wiring this all together without any proto board is pretty difficult. I'd like to point out some things here. First, the Arduino typically uses 5 volts. So why am I using 6 volts for the power supply when I can just use the 5 volt power supply that is already included in the Arduino? The answer is that each servo needs a certain amount of current, and the current coming from the Arduino is not enough. So the 5 volts coming from the Arduino is not enough. I need at least, what I found is I need at least 6 volts in series of batteries to power the servos. I don't know how much more it is, and I don't care to test it because I don't want to overheat anything. I'd rather stay on low voltage. I tried the 5 volts from the Arduino. It did not work. I tried 9 volts, and it actually, no, 9 volts also worked, I remember. But what I failed to do is I failed to create a common ground. Another thing you have to do is create a common ground. So you'll notice that all grounds here are wired together. You'll notice that the power supply, the 5 volt, is actually connected to the potentiometers, while the 6 volt battery supply is isolated to only the servos, and that's really important. I tried a lot of configurations, and I basically just figured out on my own that you need to isolate this battery supply while creating common ground, or your servos will jitter, and it is so annoying. I spent so much time trying to figure this out. It is such an elementary mistake. I should have known. Yeah, but in all my years of electrical engineering in college, I've never hit a problem where I did not have enough current. I know that exists, but I've only seen power being a problem, not current. I've never really had this problem. So, yeah, that was a first for me, so I learned a lot. Okay, so I have some notes. I need a proto board to connect grounds, and I need a spot to place potentiometers. Okay. So now you'll go to this schematic. So these are my potentiometers. If I flip this cardboard right here, I can't flip it all the way, but you'll see the potentiometers. You'll see they're all connected to one proto board to connect all powers. I mean, all red cables together to one common voltage, which is the 6 volt, the 5 volt from the Arduino, and all grounds to one spot, which is ground of the Arduino. And then I have the blue pins, which are the analog pins, and the blue wires, which are the analog pins that go to here. And then the green pins are the digital pins, which are the data cables to the servos. And then I have another proto board. This proto board is for the servos, for the power of the servos. So it doesn't matter what orientation you put the reds or the blacks in for every servo, as long as you put one in for every one in the correct spot. Yeah. As long as you put one red wire and one black wire in, it should be all good. And that's basically it for this. And then now I move on to the code. And before that, let me just mute my laptop. Okay, so this is the code. Code is pretty straightforward actually. I create 3 servo objects. I include the servo.h library because Arduino basically uses C. Those 3 servos are pretty self-explanatory because I already explained them. R1, J1, J2 grab. And then I declare the analog pins for each potentiometer here in lines 8 to 11, which align with the pin values in the analog in. It's hard to see 2 and 3. That's because I changed the what I'm connecting it with. But yeah. Okay, and then I just have some integer value declarations for some mapping the servos, like translating the potentiometer rotation to the servo rotation. Okay, and then some general stuff. The serial begin is not necessary. That is due to just testing reasons. So I attach it to certain pins, pin 9, pin 10, pin 11, pin 5. These refer to the digital pins, so the green wires. You see pin 5, pin 9, pin 10, pin 11. Okay, so then back to here. Scrolling down, we have basically the same thing going over and over again in the loop. So we have analog read, so I'm reading the potentiometer reading, mapping that to servo, and then finalizing what that does with the write. And yeah, print is not that's just for debugging stuff, which I did a little bit of. And then I do that for J1, J2, grab, and then there's a small delay. The delay is so that the servo, there's like an input maximum for the servos. I don't want them to go crazy. Like if I get massive voltage fluctuations, if a wire gets loose, or like my 5-volt and ground pins end up touching for some reason because there's 2 open metal parts that often touch each other. I don't want the servos to go so crazy that something terrible happens. So by delaying it, the servo should be okay. And yeah, that's basically it. And you'll see that my taping job was so bad my robot fell down. But yeah, yep, that's it. And hopefully I can get to the I ordered some PCBs for another project, so hopefully I can get to that later. But yeah. All right, I think that's it.